Hi class, today we are going to be looking at the triangle inequality theorem, and before we do that I want to just kind of illustrate what's happening for you. So if you have three segments, and here it says that the first one is 3.9, the next one is 4.4, and the last one is 6.2. And if you take these segments and you drag them around, and let's say you want to make those into a triangle, well, these three segments here, you can make a triangle out of those, and that will work out just fine with those three examples. But let's say I make C 10. Is there any way that I can make these three, the 3.9 and the 4.4 and the 10, is there any way that I can make those into a triangle? And the answer to that is no. These are just not long enough to be able to reach. Even if I were to go down all the way for those, they're not a triangle. So there are some segments that will work to make a triangle, and there are some segments that won't work to make a triangle. And that's kind of what we're going to be looking at today. I want to show you one other activity quick, and then we'll get into the notes. For this next one, it lets me hinge this side, and I could go all the way until that's just going to be like a segment on top of another segment, where I could have a triangle where I have like this really obtuse angle that's going to be really close to 180 degrees, or I could swing this all the way around this other way to where again it's a really obtuse triangle. And then eventually I would just get like a segment on top of another segment. So I have this whole range of possibilities that dotted line could be. Let me see what this says. Oh, I guess it doesn't matter. For that potential third side, and that's going to be really important. But there is limits. There's lower limits of how short that side could be, and then there's upper limits with how long that side could be, and still have that make a triangle. So here we go with the notes. The triangle inequality theorem actually says that the sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. So in this triangle here, what that would mean is if you add PQ and QR, that would have to be more than PR. Because otherwise, if they were exactly the same, it would just be like that example where you have that segment on top of another segment. If these two add up, so 4 and 6, if those add up to just be exactly 10, you can tell that they wouldn't actually, it kind of looks like they do here, but they wouldn't actually reach each other until they got to be exactly 10, and that wouldn't make a triangle. So what it says is one of those is going to have to be over. When you add them up, they're going to have to be more than that third side, so that when you swing these up, you get a nice triangle. And then I can do the same thing with these other sides. I can say that these two, so QR plus RP, have to be greater than the other side, the third side. And then the last two would be these ones here. PQ plus RP have to be greater than QR. So any two sides have to be greater than the third side when you add them together. The directions for these say, is it possible to form a triangle with these given sides? If not, we need to explain. So what you need to think about is you need to think, do each of those pairs of sides add up to be more than the third side when you add them together? So when you go through these options and you add those up, all of these add up to be more than the third side. So you could say that yes, this is a triangle. For this one here, when I add up 12 plus 17, that is exactly 29, and it has to be more than 29. So because 12 plus 17 is not greater than 29, I would say no, and this really is just my explanation showing the one thing that doesn't work. If you wanted to include the other ones, you can. but remember, it just takes one example to prove something's not true, and this would be that one instance. For this one here, if I add 2 and 11, that's more than 8, but what happens when I add 2 and 8 together? Well, that's less than 11, so I could just say that 2 plus 8 is not greater than 11, and then write not a triangle, and then this would be my explanation. For this last one, any two of these sides add up to be greater than 15, or add up to be greater than the third side, and you could write that out. And let's see, I got 21 and 15 is greater than 14. So yes, this one would be a triangle. Just check all of those, and really, I guess if you want, you really just have to check the smaller two. If the smaller of the two, maybe I'll write sum of the smaller two sides is greater than the longest side. That's one way you can double check with just really adding one of them together. But I just want to point out that they won't always be smallest to largest. Just be careful of that if you're just, checking the one. Okay, for this next one, it says we want to find the range for the measure of the third side of the triangle given these two. So I don't know the third side. I'll just call it x. But I do know that 5 plus 17 has to be greater than x. I know that 5 plus x has to be greater than 17. And lastly, I know that 17 plus x has to be greater than 5. So what I would do is I would just think about what each of these are separately. So 22 has to be greater than x has to be greater than 12, and x has to be greater than negative 12. Well, because I have these three inequalities, really you're just kind of looking for the two of them that make sense within this list. And if you're not able to just recognize that, you could always think about the number line. This one here is saying that x has to be less than 22. This one here is saying that x has to be greater than 12. And I could do some open circles for those. And this one's saying that x has to be greater than negative 12. And because this is a triangle, that doesn't really make sense. Plus, that doesn't fit within like everything that this one says. So I don't really need that in terms of this problem. So what I would do is I would just write... Okay, no problem. I would just write that x has to be between 22 and positive 12. And if you want to write that out, x is between 12 and 22, that's fine. This is the way that I usually write it when I'm doing these because that's what that means. So there is a shortcut for doing this, and the shortcut is when you think about what that picture looked like a minute ago that I showed you at the beginning. So if these sides are 5 and 17, if I'm looking at those, the very longest that this could be, well, if it became 22 when you add the 5 and 17 together, that would be a little too long, but it could be like 21.9 and make a triangle. So it has to just be a little less than 21. If I swing this all the way back around here, what I'm doing is I'm finding the distance between the 5 and the 17, or the difference between those numbers, meaning I'm subtracting those. So it can't quite be 12, but it could be just a little bit more than 12, like 12.1, or even 12.001. So I just write that it's greater than 12, but less than 22. So I wanted to kind of talk you through this because it'll be important for the next one. But really, essentially what you're doing is you're just saying, okay, 17 minus 5 is 12. That's your lower end. And then 17 plus 5 is 22, and that is your upper end for this. So the rest of these you can do pretty quick. If it has to be making a triangle, the range of sides has to be anywhere between, when you subtract those, you get 18, and when you add them up, you get 34. So that third side, I'll just call it x, has to be greater than 18 but less than 34. And you could just write your answer like that and be completely done with it. Okay, and then for this last one, the reason I talked you through all of that other stuff is because when you get to this, you simply can't do it the same way. But what you can do is you can write out 3 inequalities and check and see what happens. So remember that any 2 sides, when you add them up, it has to be greater than the third side. So in this case, for this first one, I just added those 2 up and set it greater than this one over here. So when I solve that, I get 2x plus 5 is greater than 3x minus 2. Or I can say that x has to be less than 7, or 7 is greater than x, whichever way you choose to write that. I'm going to just repeat this process for these other 2. So I'm going to add these 2 up. So 4x plus 1 has to be greater than x plus 2. And I'm going to solve that to where 3x is greater than 1. So x has to be greater than 1/3. And then the last one, when I add these 2 segments, so that's going to be 4x, and then it'll be plus 0, so I won't write that, is greater than x plus 3. When I solve that and subtract that over, I get 3x is greater than 3, or x is greater than 1. Again, I need to kind of think about what's actually happening here, because one of these is going to be obsolete. If I'm thinking about like a number line, if that's helpful to you, this first one is saying that x is less than 7. So that's everything at 7 and this way. This one is saying that x has to be greater than 1/3. So that's everything that way. But then this one kind of trumps it, because this one is saying that x has to be greater than 1. So that one there is really not needed. And I can just say that x has to be greater than 1 but less than 7. Or in other words, x has to be between 1 and 7. And that would be our range of possibilities. So you'll practice this in class, and hopefully when I get back, we can talk about it and go over it if you have any more questions. Make sure you're checking your work as you go, and help each other out.